problem. Someone is pulling a 5 kilogram box to the right, and it's our job to figure out what the friction force is and the normal force is, given that the box is being pulled at a constant speed. Step 1, we draw all of our forces. Here's my force of pull, which is 40 newtons. Normal force is going straight up, force of friction to the left, and force of gravity is going straight down. Step 2 is positives and negatives. I'm saying right is positive, left is negative, up is positive, and down is negative. So now, what we have to do, our third step, is any force that is at an angle, which is only this one in green here, force of pull, we have to break into its components. So we are going to pick a color. Let's go purple for the part of pull that goes to the right, which is F of P. I'll call it in the X direction, force of pull in the X. And now there's also a force that pulls straight up. And we'll do that in, how about white? So that is force of pull in the Y. So now we have to figure out what those are. And we can do that doing our right triangle geometry. Force of pull in the X, that's the adjacent side of this triangle. So that's going to be cosine of 30 degrees multiplied by the force of pull itself, which we know is 40 newtons. And when I plug that into my calculator, what I will get is that the force of pull is equal to 34.64 newtons. Now I'm going to do the same thing for force of pull in the Y. But for force of pull in the Y, that's the opposite side of our triangle. So it's going to be the sine of 30 degrees multiplied by the force of pull itself, which is 40 newtons. And I find out force of pull in the Y is equal to 20 newtons. Now we can go to adding up all the things that go left and right and all the stuff that goes up and down. We'll do left and right first. So our forces that pull to the right, that is just force of pull in the X direction. And our forces that pull on the left is just force of friction, so that's minus force of friction. And all that is going to add up to be 0. So we know that they have to equal each other. So force of pull in the X equals force of friction. And since we did the previous step, we know the force of pull in the X direction right here is 34.64. So we know that the force of friction is 34.64 newtons. So that's one answer. Now we're going to figure out what the normal force is. We're going to add up our up and down stuff. So we add up our up forces, which is the normal force, plus force of pull in the Y. Most common mistake people make is they forget about this one. Don't forget about it. It's on our picture. It's going upward. And we're going to subtract the force of gravity. All those add up to be 0 since this is an equilibrium problem. We're going to rearrange to solve for the normal force. So that's going to give us normal force equals the force of gravity minus the force of pull in the Y direction. And the force of gravity is mass, which this thing has a mass of 5 kilograms times 9.8 meters per second squared minus our force of pull, which is 20 newtons. We plug that into our calculators, and what we should get is an answer that the normal force is 29 newtons.